All right, hi everyone. Welcome to the first meeting of Batch Working Group. As you may all know, this meeting is recorded and will be uploaded to YouTube. So please adhere to Kubernetes community standards in meetings. Let me start sharing the agenda that I had in mind for the first meeting. All right. Can you all see my screen?
Yep, we can see it. You can make it the font a little bit bigger.
I can make it bigger.
Yeah, it will be nice. If you zoom the page, it will be much more readable.
Oh,
because it's like less than half of the page.
Right. There you go.
Oh, perfect.
And this, and maybe. All right. So yeah, welcome to the first meeting. As you may all know, this working group will be focused on enhancing batch support within core Kubernetes. And we have a charter. I hope that you've looked at the charter, which defines the scope of the working group. I thought we can discuss the charter today as well. As you may all know as well, we've got a couple of meetings. So we have a meeting every week, but they are on alternative days. The first one is basically today, every Thursday at 7 a.m. Hopefully this is friendly to Europe and East and the East, like East Asia. And the other one is at 3 p.m. Pacific time. It's the same day on Thursdays. We've got the calendar here as well, and we will be starting uploading these recordings into a YouTube channel. We have the link here as well. So we've got also a Slack channel within Kubernetes. It's the working group batch. So please feel free to ask questions there. The organizers, let me open this link. So I'm just one of the group. We've got Wei, he's a SIG scheduling lead. We've got Danielle. I don't think she's with us today. She couldn't join. She's an expert on node performance. Maciek as well. He's well known SIG apps. Did a lot of work with the job API in the past and cron job as well. And we've got Swati, our expert on HPC in general, and she's co-leading the effort to improve support for NUMA aware scheduling within Kubernetes. So we've got like a really nice group of organizers. But I want to emphasize here that like the set of organizers are mostly moderators. We want to try as much as we can to basically move wherever the community wants us to move and focus on. It's not that we're going to impose any direction per se, as much as we will try our best to understand where the community wants to tilt and you know, use our expertise in these various SIGs to help understand how we can move forward with the batch mandate or batch charter. Okay, so with that said, welcomes and introductions. Probably you know, like my name from the screen. Again, like my name is Abdullah. I'm a SIG scheduling lead. I've also introduced my co-chairs as well. So I've got I think we have a lot of people. I don't think we can do a round of introductions today. It will take a long time. But please, if you want, introduce yourself in the Slack channel. It would be nice to understand what your interests are, why you're joining the working group batch, so that it would influence again our agendas in the future. In general, if you have any topics that you want to discuss, again, like similar to typical Kubernetes SIG meetings, please feel free to add the agenda item into the agenda doc for the next meeting. So how we operate, so again, as I mentioned, we want to make sure as much as we can that we want to advance the batch use case. We want to define high-level pillars that we want to advance so that we're kind of focused. Batch is a massive area. So we want to make sure that we're efficient in the way that we operate. We want to identify, a number of issues that we want to address. At the higher level, as mentioned in the charter, our first exit criteria as a batch working group is to define recommendations of enhancements that we want to apply into core Kubernetes. And so the respective SIGs would execute on them. I do believe that we can start executing before we exit. Like we want to, for example, discuss enhancements to the job API. It's not that we're just going to write that enhancement proposal or open an issue and that's it. It would be great if we can start making progress on that as well. And so, but at the end of the day, I really feel that, again, we want to be efficient, make progress. And that's why I would like to start by discussing a high-level roadmap, and then maybe we can even document it and write it. The charter just sketches very high-level areas of interest, but we need a much more concrete roadmap. And before I get to that, I want to pause here and see if anybody else have any questions related to this long introduction.
I have one. So part of what I've been working on is trying to figure out where the kubelet should be going, because it's not very mutable as far as resources underlying, right? Unless the features are specifically added to the kubelet. So there's some movement, it looks like, and interest, a lot of interest in getting a resource management plugin model as opposed to the current model where any resource management items have to be put in tree, right? Where would that fall? Is that an interest to this group that I should be bringing back?
So are you referring to the dynamic resource allocation that Patrick is working on?
No, I'm talking CPU and memory, not just regular resources.
Is there like a more, is there like an issue open or a cap already open being discussed?
There's some discussion in channel. There's not a cap at this time because I'm still trying to get together the requirements and what sorts of solutions would be okay. When I spoke with Derek Carr and Elena Hushman, they are also interested in this. But it would require quite a bit of re-architecture of the current kubelet in order to do it.
Right. So this is like a great topic to discuss under like the pillar of removing frictions to use special hardware, and even like in your context, probably even I don't know, types of. I'm assuming you're referring to some tunings at the CPU level, right?
CPU level, and that includes NUMA, power, and memory placement.
Right. Yeah, I think it fits under this pillar. But again, before that, I wanted to understand, try to get some sort of a consensus or agreement how we operate across these three pillars that we have discussed in the charter. Again, what you mentioned could fit under this pillar, but I don't know if the group has the capacity to invest in that direction. I don't want to impose that. And so it is definitely something we can we can discuss. It would be better if we have like an issue, at least an issue within core Kubernetes that you can reference, so people can get a better context of what exactly that you're proposing we pursue.
Yeah, I understand. Okay. There is a CPU management doc, but that's pretty all over the place. It's not concise.
Right, and like in my mind, CPU management, memory, like the memory, like doesn't that fall under also NUMA in some sense, or it's probably more, right? Like it's also about pinning.
It's NUMA, what types of CPUs, which will
Right.
include the stuff that you are working on, because if you're trying to get high performance, certain CPUs sometimes are better
Right.
for some things than others, right?
Yeah, I think it does fit squarely under that third pillar. Any other questions? Okay, sounds good. So yeah, as I mentioned, like one way of trying to work on that roadmap, which will give us a little bit more direction to how this working group going to make progress, is to try to start with classification of batch workloads. And like we in the charter, we already discussed 3 areas, which one of them is the job API, the second one, the job management, the third one is removing frictions to use like special hardware. But those are like 3 areas of feature sets that we can do. I'm trying to understand if we can have a batch workload classification that we can project on these features and guide us. For example, for the job API enhancements, we've done a couple in the past few releases introducing index job. But is that enough to model MPI workloads? Is that enough to model reinforcement learning, machine learning, reinforcement learning workloads? Is that enough to model Spark workloads? What other enhancements do we need to do to make sure that communities like Kubeflow can build on these core features that we are trying to develop here? Again, the idea is not to impose something on the overall community as much as finding common ground to move people from just creating plain pods, doing lifecycle management to things that everybody is doing. For example, like I can mention one example here with MPI. It's like it seems that it's reasonable to model it as an index job, for example, with index number 0 being the driver, and the indices basically define identities to the workers, and so they can address each other. So same thing with probably with reinforcement learnings. Like you have 2 groups of pods. One is that I don't know what they call, like parameter servers and the workers. And you can model, you don't need to model everything as a single job, but you can model them as 2 V1 jobs, for example, and so forth. So one thing like I would love to start with is really define the type of workloads, high-level workloads, batch workloads, that the community is interested in. I've seen people, for example, interested a lot in Spark. How do we do dynamic, scaling of Spark workloads? So that is one thing. The other thing I would suggest that we discuss in the again in the roadmap is projecting this categorization into the types of like the 3 pillars that we want to address, which is the job API, job management, and on-node enhancements related to special hardware. Does anyone have any questions, or like, does that make sense?
It makes sense. Yeah, go on, Claudia, sorry.
Oh, yes, you're good. Okay, so for the job API, it, building batch workloads such as MPI, TensorFlow, Spark. So what does it mean exactly that the idea would be to create and to enhance the job API with labels or something, or create new objects? Just thinking about the MPI, once we
Right.
there's the MPI operator. So how do those things go together?
Right, that's a great question. So the idea is not to actually implement MPI in core Kubernetes, but to make the job API that we have a building block to the MPI operator. For example, again, we introduced index jobs. That was a step in the direction of having the MPI operator relying on the job API rather than creating their own, like creating raw pods. Another enhancement that we can do is, like Aldo in the past suggested, is in the status of the job, like for example, the MPI job could be modeled as a V1 job, right? Like the MPI operator would create a V1 job, but it needs enough features in the job API to do everything that it wants to do, right? So as I mentioned, the index job, that's one thing. In the past, they tried to model it as a stateful set, for example, but that didn't work. So we're trying to fix this and make sure that the job API addresses these shortcomings. Another thing is improve the job status with ready pods, and Aldo can discuss this, have an issue about this as well. For example, like when the job API, when you create a job, we want to track which pods are ready, right? And those are like basically that the MPI operator can watch for, and only then, for example, it would create the driver. So along these lines, we're not trying to implement MPI, we're not trying to re-implement Spark or TensorFlow. We just want to make sure that the job API is, you can use it to model all these things.
Are you also considering, and I think, correct me if I'm wrong, but currently the job API, you just have one pod spec, which essentially means you're dispatching one image with multiple replicas. Is a consideration also to do multiple pod templates?
So we've discussed this before. So far, there has been some resistance from API machinery to do that, but I think it's also on the table. Like if there is enough momentum to say, okay, we need V2 job API that, like, you know, with multiple templates, I think that's on the table. But at the end of the day, again, like we're not trying to push too much downstream. Like you could imagine that the MPI operator itself, if it wants two types of two types of pods, the driver and the workers, they can model them as two jobs. And so the MPI operator would be managing two jobs. So it would be left to the higher level operator to manage multiple, let's say, templates rather than trying to push everything downstream. We need to understand where is the line, right? So that's the thing where we can say, no, we're not trying to impose too much into the overall community. We're just trying to build these smaller building blocks that are robust enough and generic enough to build on top and not rely on pods directly.
Okay. The reason I'm asking is because I was just curious about the scoping of just using the job as the only artifact for delivery in this case. And many of the workloads that I've worked with, they don't necessarily use jobs. They use deployments, stateful sets, and they have multiple sets of those. And I know job is for run to completion, but they take advantage of these other artifacts in Kubernetes of the different types. And then internally, they set up their workload to actually run to completion and delete these objects. So I just was curious with regards to the focus here. Is it just going to be just the job, and we want to expand that?
I wouldn't primarily focus on the job itself.
Okay.
Since I'm representing the workload side of the Kubernetes project, if we see a general desire to improve additional APIs outside of just the batch, Aldo and Abdullah added the batch initially because that was the obvious answer that yes, it will be definitely improved as part of the changes, but there's nothing stopping us from proposing changes to additional APIs within the workloads group. So yeah,
That's great to
it's
hear.
definitely on the table.
That's great to hear. Thank you.
Right. But like I think like in my opinion, it would be better if we try to say, okay, what is missing in the job API before we say, okay,
Yeah.
we did that again. Like stateful set was being used to represent these types of workloads that needs to identify workers by ordinal index, and so I say, okay, I mean, we should be able to do that with job, but at the same time, you'll be able to have some of these indices to actually run to completion and finish. With stateful sets, you couldn't.
Right, exactly.
So yeah, exactly. So I think our priority should be actually improving the job API to make sure it works well, and that actually will give a really powerful tool for operators like providers, cloud providers, to do more optimizations. Like if we understand that if you, like most of your batch workloads are actually at the end modeled as a job, then it will be easier for us as providers to do optimizations at that level, right? Like it's easier for us to do statistics and, you know, collect metrics and do all these crazy stuff, right?
Yeah.
If you're creating raw pods, it's hard for us to do anything with them.
Yeah, I agree. Okay, great. Thank you.
I want to add another motivation for why external frameworks should be using Kubernetes APIs instead of, workload APIs instead of raw pods. Recently, we fixed the job API to be able to track all the pods that completed, even if they are deleted from the API server. And we fixed it for the job. But now people are trying to use Airflow or Argo or these other frameworks that today they use raw pods, and they have the same bug that we used to have in the job API. So, and it was not a trivial implementation. It was quite cumbersome to do. So if we already fixed the job API, it's easier if the community can just use it instead of having to fix the same bug all over again. So that's a very very important motivation. I mean, this is just one example, but there could be other pod management issues or bugs that we could solve once and for all, right?
Yeah, that's a great point.
That's great.
Go ahead.
No, I was just agreeing that that's great. Thank you.
Yeah, and specifically, like what Aldo is referring to is basically job like pod tracking. If every controller creates raw pods and these pods just go away because the node got preempted and the garbage collector took the pod object completely, you lost tracking. And so the only way to solve this is to inject finalizers, and for your custom workload controller to manage these finalizers, when to inject them, when to remove them, etc. Why they shouldn't be doing all of that? They just let's let them create the job, V1 job. The V1 job will do that. Tracking for them, and that should be universal across all types of batch workloads, I guess. So that's like just speaking more concretely to Aldo's point. The other high-level item here is job management. As you may all know, we've started a sub-project called Q. It is a sub-project under Kubernetes SEGs. We had a proposal that we've presented to SEG apps before. It's published. We've got a ton of comments and interest from the community. So that is our framework that we're proposing to start thinking about high-level job management, queuing, dynamic resource allocation, provisioning, and all of that. So this is the second high-level item. Go ahead.
I have a quick question. Sorry, Abdullah. Will you be evaluating other solutions like this as well? Like I work on maintaining the Flink operator, and we have a bunch of we have a custom resource which spawns a bunch of like stateful sets and other things, and we want them to be provisioned together or none at all. So we were using Volcano scheduler for that. Will you be evaluating other schedulers as well, or
Right. So the high-level charter of the working group is to try to introduce new features that work well with core Kubernetes controllers. I don't know, like maybe if someone else wants to I don't know what you mean by evaluate here. Like Volcano already exists, right? I'm not sure how much traction it has got so far. But Volcano is a second scheduler. So it's something that is like compete with Kube scheduler. And that is like something in the charter that we mentioned. We don't want to do that at all. We don't want to introduce new components or work with components that replicate existing functionality within core Kubernetes. We would like to work with the mindset of how can we complement what we have to introduce new capabilities. But feel free to disagree, and if you feel strongly about this, it's also on the table.
I mean, it would be convenient if the existing scheduler had this possibility of like grouping resources and scheduling them all together. Or for example, just checking how much resource quota this namespace has and only then scheduling it in that namespace, like scheduling
Right.
those pods. Yeah.
So
yeah.
Now I'm speaking like with a SIG scheduling hat, co-chair hat, and Aldo here can also disagree if maybe Wei as well when he joins next time. But from my perspective, the Kube scheduler is a pod to node scheduler. It's a pod scheduler. Doing quota checking and doing all or nothing scheduling at that level is not going to be scalable. That's why we are proposing this new approach. If you want to do job level management, you need that controller that does job level management and is specialized in that. And so we have this separation of concern where you have the controller that does job level management that injects scheduling directives that forces the Kube scheduler to act the way that this higher level job manager decided to do. Take a look at the Kube proposal. It does touch on some of these aspects, the way that at least some of us see how these things fit together, and why we've been resistant to introducing these types of collective or bulk management of pods within Kube scheduler.
All right, thank you.
Sorry, but nothing should stop us from enhancing the experience of using Volcano. Like if there is something in Kubernetes that we can do to make Volcano's life easier, I think we should do it.
Yeah.
It's just a matter of finding what's the right set of features that would help. But yeah, this idea of managing workloads instead of managing pods, I mean, it's not the first time. It's not the only idea over there. I think Alex is here. Alex is also he also has another scheduler, job queuing system, which works a similar way, and it kind of looks at quotas. I don't know if I don't want to put words on Alex's mouth, but yeah, if we can find a common ground of a set of features within core Kubernetes that can serve all those purposes, I think that would be a win for everybody. But again, I'm also with I also have the idea that we should we should try to build on top instead of replacing stuff, or enhance some features so that you don't have to replace them anymore. That's my point of view.
I'd like to add a point here, if I can. Like apart from Kubebatch or Volcano, like we have other schedulers that are managed by multiple companies and entities. Like the community is, in terms of Bash, it is already fragmented. And the main thing that I think what Abdullah is trying to say here is like, what are the use cases? Why is another scheduler needed? What are the use cases that we are trying to solve? If they can be solved via the core Kubernetes, we should try to have those features included in the existing workloads API. I think I agree to that part, but one thing I would like to add is whoever is owning those individual batch schedulers, I think they should also do some research and then identify, like, for example, we have the existing queue, right? I mean, can we make sure that the Volcanoes API can fit into this with the existing mechanism that we have? I mean, like as a community, we are not going to force anything, but I think understanding those gaps can actually enrich the existing workload API. That's something that should be driven by the individual project owners. But I think if there is a feedback, we are, I think, ready to accept. That's what Abdullah is trying to say.
Yeah, makes sense. I mean, yeah, I'm also a user of Volcano, just clarifying. I don't really, yeah.
Yeah, and we have some schedulers that are owned by IBM folks as well, and they have some experience running those batch schedulers. So one of the things that we are trying to do is evaluate the existing queue API, see what are the pieces that are missing, and see if we can make sure that those schedulers can conform to this API if possible. If not, what are the gaps? I think as a community, like if the individual project owners can do that, this group's charter will be much more successful.
Ravi, I want to mention, Diana here has a job scheduler, right? So that can be one of the things that maybe in one of those meetings we can look at, the design choices there and see if some of them, make sense to, adopt or enhance this proposal. And you mentioned another person, I think, on the group who has another job scheduler. Or queue manager, right? I'm using job scheduler and queue manager interchangeably here. So I think it would be a good idea, right, to kind of have those proposals or those actually, working solutions presented and see if there are any design choices that make sense really to be, adopted here.
I think this is a great idea. I think could be one of the things that we do as a part of our roadmap, part of our progress, making progress in this specific pillar, is to do like a call for participation. Get these projects to present to this working group their schedulers. What do they see missing in core Kubernetes that they had to implement at their layer? What is their, like, I would call it like theory of operation? This is something that Tim Hawking keeps using. Like how do they see managing a job, or how do they manage a job? Like, do they manage it as a group of pods, or do they manage it as just like, a job, high-level job, like, resource, and the pods are managed by the specific workload controller, etc. So there are multiple ways of, I think, different schedulers have evolved, and we can start there. I think that's a great idea.
Yeah, I think the other advantage is like the community as of now is fragmented, but we can all rally behind a single API. Say if we can come to a common ground that this is what at the core, all the schedulers would like to have this set of functionality, and this can be envisioned via this particular API. I know this is hard, but I think that can actually ensure that the community is not fragmented anymore.
I completely agree. Go ahead, Al. Sorry.
Yeah, going back a little bit to Q, we have a set of APIs that we share, but from my point of view, I think they can be those set of APIs could even be split into something that is clearly common, like the workload API, and something that is maybe more business dependent, like modeling capacities, or some people call it they call it queues, they call it quotas. So maybe that part can be split out and leave it to people to decide how to do it. But maybe at least we can agree on lower level APIs, such as the workload. Mhm. Or maybe we can split the cake somewhere else. That's something we can discuss right now in this forum.
Just one comment. One thing I'd find very useful would be for each of these focus areas, if we can kind of narrow down the pain points and the challenges that are being encountered by people, that would feed into kind of requirements, that would give us a more holistic view in terms of what we want to achieve in each of these focus areas. Because I think, like Ravi said, it is a bit fragmented in terms of what different people are working on. So that kind of help collate some of this information and give us more clarity for each of these focus areas. As an example, like for the third piece, for the hardware acceleration and NOMA awareness. So it involves CPU management, topology aware scheduling, and then we can maybe have a statement corresponding to like the topology aware scheduling piece. This is the gap and this is what we want to achieve and solve maybe in the core Kubernetes API itself.
This is like a nice segue into what I wanted to mention. Like these three pillars, I think we need like quote unquote lead that pushes each of these pillars forward and tries to organize the effort exactly as you mentioned, identifying the key areas that we want to focus on, and that would make this group more scalable. I'm not saying that those are going to split into different groups. It's going to be the same group. But we want a point of contact that is organizing the efforts and the progress we're making in each of these three pillars. What does the community think about like this high-level organizational approach?
I agree with that as well. I think one of the things we should do is maybe set a baseline in terms of what the current state is as well. Like, because if people, for example, myself, Francesco, Marlo, we've been probably more involved in the node side of things. So it'll be interesting to understand the work that has been done in, say, the job API, job management point of view in scheduling area. So if we set that baseline, it'll help the group overall.
So do we want, like, for example, I could start by proposing like a template for these three pillars, as you mentioned, and then we can iterate over that template. Basically, how we're going to start making progress in each of these pillars. As you mentioned, we can start with defining this, like what is the current state within core Kubernetes. What are the main areas that we would like to we understood or we learned that they are they have limitations and we can list them, and then we take it from there. We develop this as collectively being our roadmap.
Yeah, sounds good.
Current initiatives too, whatever is in progress.
Yeah, this is what I mentioned by like the current state. Oh yeah, right, current state within core Kubernetes and initiatives as well.
I think that sounds great.
Okay, we're out of time. Thank you so much. This has been great. I'm really excited about this working group, and I hope I really hope it will be successful. We can produce something that gets pushed into core Kubernetes and makes Batch a first-class citizen of some sort compared to, you know, just like services.
This is great. Thank you so much.
Thank you all.
Thank you. Thank you for organizing this, Abdullah.
Yeah.
Thanks,
Thank you.
Abdullah.
Thank you. Bye.
Thank
Bye.
y'all.
Bye.
Bye.